In this question, we're given a diagram which shows the positions of three towns: Acton, Boston, and Chorlton. We're told that Boston is 8 kilometers from Acton on a bearing of 37 degrees, and Chorlton is 9 kilometers from Boston on a bearing of 150 degrees. Now we need to find the bearing of Chorlton from Acton, giving our answer correct to 1 decimal place. Now looking at our diagram, we can see that we can create a triangle ABC, and this triangle will help us to find the bearing of Chorlton from Acton. Now this bearing would be equal to the angle labelled in green. But now let's make a copy of this diagram below and add in lots of different angles that we'll need in order to find this bearing. Now you can see that we have lots of different colours and lots of unknown angles that we'll need to find out in order to find the bearing. Now looking at this diagram in front of us, the bearing of Chorlton from Acton would be equal to 37 degrees plus the angle A. Now we can start by finding the pink angle. We know that co-interior angles add up to 180 degrees. We can see that the pink angle and 37 degrees are co-interior, and so the pink angle would be equal to 180 take away 37, which is equal to 143 degrees. The next angle that we can find is the orange angle, labelled B. We know that angles around a point add up to 360 degrees, and so we can say that angle B is equal to 360 take away brackets 150 plus 143, which is equal to 67 degrees. Now that we've found angle B, we can use this in order to find the length of AC. We can find the length of AC using cosine rule, which we know is A squared equals B squared plus C squared minus 2BC cos A. We can substitute in the values below. We can say that AC squared is equal to 8 squared plus 9 squared minus brackets 2 times 8 times 9 times cos 67, close brackets. Now putting this into our calculator, we can see that AC squared is equal to 88.7347 ... and we can find the length AC by finding the square root of this value, and so we can see that the length AC is equal to 9.419910695 ... kilometers, which we can also label on our diagram. Now we can find the blue angle, labelled angle C, and so we can use sine rule in order to do this. Using sine rule, we can say that sine C over 8 is equal to sine 67 over the length AC, which we found was equal to 9.41 ... kilometers. Now we can cross multiply and say that 9.41 multiplied by sine C is equal to 8 multiplied by sine 67. We can divide both sides by 9.41, and putting this into our calculator, we can say that sine C is equal to 0.78175 ... And using the inverse sine button on our calculator, we can say that the angle C is equal to 51.42131.479 ... degrees. Now using all of the information we've found, we can find angle A, which is in green. We know that angles in a triangle add up to 180 degrees, and so we can say that the angle A is equal to 180 take away brackets 67 plus 51.4, which is approximately equal to 61.5786 degrees. Now we said that the bearing of Chorlton from Acton is equal to 37 degrees plus the angle A, and so we can say that the bearing is equal to 37 plus 61.5786, which is equal to 98.6 degrees to 1 decimal place. But remember, we need to give our answer in the format of a bearing, and so we need to have a 0 in front of the 98. And so we can say that our bearing of Chorlton from Acton to 1 decimal place is equal to 098.6 degrees to 1 decimal place. Now this question is worth 5 marks. We get the first mark for finding that angle B is equal to 67 degrees. We get the second mark for finding the length AC using the cosine rule, and for finding that AC is approximately equal to 9.42 kilometers. We get the third mark for using sine rule in order to find that the angle C is approximately equal to 51.4 degrees. We get the fourth mark for using the fact that angles in a triangle add up to 180 degrees, and for therefore finding that the angle A is equal to 61.5786 ... degrees. And we get the fifth mark for using the information that we found in order to find that the bearing of Chorlton from Acton is equal to 37 plus 61.5786, leaving us with an answer of 098.6 degrees to 1 decimal place. allowing us to get the full 5 marks needed in this question.